Yeah, good morning, all of you. Today we will try to discuss one of previous year gate question from D.C Machines. So here we can see the previous year gate question from the D.C Machines. So I will try to read out the problem first. A separately excited DC motor has an armature resistance of 0.5 ohms. It runs from 250 volts DC supply, drawing an armature current of 20 amps at 1500 rpm. For the same field current, torque developed for the armature current of 10 amps will be. So just you can see here clearly they have mentioned that this is the separately excited DC motor. Separately excited DC motor. So what they have provided the data. So already we know the circuit diagram for the separately excited DC motor. As you can see here, this is my field winding of a separately excited DC motor. So this is the voltage applied to the field winding, that is VF, and the current flowing through the field winding is IF, and the terminals are Z and ZZ. And at the same time here I am going to draw the armature side circuit. Just you can see here, this is my armature circuit DC motor. And so what is the voltage applied to the motor is, armature is 250 volts DC supply, 250 volts DC supply, and it draws the current of 20 amps, current of 20 amps, and it runs at a speed of, and it runs at a speed of n is equal to 1500 rpm. Okay, so what we need to find out, we should need to find out the torque, am I right? Torque for the same field current. What is the formula to find out the torque? Torque is equal to, okay, now EB into, torque is equal to EB into IA, power. EB into IA means power by, okay, now omega, speed, angular velocity. Okay, now so torque is equal to P by omega. So P is equal to EB into IA, so that we should need to find out the EB, back EMF. Okay, now EB is equal to what is the formula to find out the EB in a separately excited motor? So where the EB is developed, EB is developed inside the armature, so that you can apply KVL to this loop. Okay, now EB is equal to V minus IA into RA, V minus IA into RA when we are applying KVL to the armature circuit. So what is the voltage they have provided? 250 volts, 250 volts minus what is the armature current? 20 amps, and what is the resistance value? 0.5 ohms. Okay, when we can solve this, we got 240 volts as the answer, EB. So EB is equal to 240 volts we got. And then next we can find out the torque is equal to, okay, now EB, what is the value of EB? 240 volts into what is the current? Armature current. See here, the armature current is 10 amps now. Okay, now for the same field current, okay, now clearly they have mentioned that for the same field current in the previous case and now also the field current has been constant. For the same field current, the armature current has been changed, okay, now to 10 amps. So we should need to consider 10 amps by omega. Omega is equal to 2 pi n by 60, 2 pi n by 60, so that 240 into 10 into 60. Okay, now 60 comes to the denominator. Okay, now 2 into pi into n. What is the value of n? N is equal to 1500 rpm. So by solving this, we got 15.2788 Newton meter. Newton meter is the units for the torque. So this is the solution for this given problem. This problem has been given in 1992 as a 1 mark question. So here we should need to know the clear circuit diagram, then only you are able to solve the problem, and at the same time you have an idea about the torque equation. Torque is equal to P by omega. Here omega is the angular velocity, radian per second. Here the speed n is the rpm, revolutions per minute, rpm. So here I'm considering in a radian per second, but they have provided the speed in rpm. So this is the solution for this question, and my final answer is 15.2788. Thank you.